workshop is protection against over-voltage, lightning protection and surge protection. To put simply, lightning protection is the protection of a structure from a direct lightning strike. Lightning is the most spectacular form of an externally generated surge. However, it is estimated that 65% of all transients are generated internally within the facility by the switching of electrical loads such as lights, heating systems, motors, office equipments, etc. Though lighting is not the most common transient event, it is the most significant and is most likely external cause of significant surge. So to tell you all in great depth about the protection against the unnatural event of lightning surges and protection against over voltage, lightning protection and surge protection, we again would like to have on the stage it once again Mr. S. Gopakumar. The stage is yours, sir.
So now we are reaching the last session. Not exactly the last session, but the last technical session. Then after that we have the panel discussion. One moment. Can you give me a paper to keep it here? One moment, please. By mistake, I closed my presentations. There is a small trouble because of the internet. One moment. Because nowadays we all of us work with everything online. Sometimes if the laptop is not syncing, the file is gone. So like that, a small trouble. But luckily here we have 5G and the speed is good. I ensured that in the morning this was perfect, but now anyway it was asking to sync with the server. So we are going to talk about lightning protection and surge protection. But please note that talking about the complete lightning protection in 1 hour or 1 hour 15 minutes is an impossible task. I will try to cover upon some, or I will give some tips about lightning protection. So rather than claiming that a big presentation on lightning protection, let me make on some tips on lightning protection. Oh, one moment, still the problem is not solved. Can you show the screen? Oh. No, I have it. Is it okay now? Oh, again it's sometime the security things are good. Sometimes it is too complicated. There. No, I made it. Yeah. Right. So, lightning protection of buildings and electronics. I will try to cover both external lightning protection and protection of electronics. But please note that I am not going to cover the entire subjects of lightning protection. I will try to cover some important tips or try to cover as much as possible in 1 hour. The first point is BIS documents are categorized into code of practices and standards. Code of practices are documents which is having some legal validity. IEC 62305, even though it is written as a standard in the outer cover, actually it's a code of practice. The earlier version, IS 2309, the name itself was Code of Practice for Lightning. 62305 is also a code of practice. Unfortunately, not printed on the cover page, but this information is available on the BIS. If we ask for the list of, there are some places where the code of practices are listed. So now in the new regulation, especially the regulation 14.2, which says code of practices are mandatory. Also in regulation 38, sub-regulation 4 says all buildings more than 15 meters, all these standards has to be followed. Of course, the same contents are also repeated in the National Building Code. Same contents are also repeated in the National Electrical Code. But probably in the next version of National Building Code, the idea or the decision is to, instead of writing so many things in the National Building Code, only the references will be made in the National Building Code, so that the architects or the involved engineers, they know that for this subject refer NEC or the respective standard. So this change probably is going to come in the future version. With respect to standards, you are aware that these standards are made by, in IEC, these standards are made by a technical committee called TC 81, which is where India is a member, permanent member. Experts from about 61 countries are participating in making this particular standard. There are several working groups and maintenance teams, and all these teams together, each of the team takes care of a particular subject. All of us together are making this standard. I am a member from India not in the entire technical committees. I am a member in some of the about 8 or 9 technical committees. So sorry, not in a technical committee, in a working group. The nation is the member in the technical committee. An individual cannot become a member in the technical committee. The country is the member. Inside the technical committee, there are working groups. And so I am a member in the working groups of the technical committee. So I cannot claim that I am a member in the technical committee. No, India is a member in the technical committee. Now the standards which is made by this TCEC 81 is 62305 part 1 to 4, which talks about protection of lightning. Then 62561 part 1 to 8, which is about the components used for lightning protection. 62713 is about safety procedure of risk reduction outside structures. 62793 thunderstorm warning system, lightning density based lightning locating system. See, in future, at the moment what we do is, you have a building, we make a risk assessment, find out what best or how economical you can make a lightning protection, and based on that we put the lightning protection system. But in future, probably the risk assessment will have few more questions, which says, are you able to predict the lightning before it strike, or are you able to find out whether the lightning is going to strike maybe half an hour before, so that the risk can be avoided. For example, those who are outside the building can be put an alarm so that people can go inside the building. If you have some kind of explosive activities, sometime in the explosive area some fumes are going out, those can be stopped temporarily for a certain time. As a result, risk reduction may be coming in future. With respect to the second subject, surge protection, one of the main component of internal lightning protection consists of shielding, bonding, cable routing and surge protection device. It is not only like, buy an SPD, put it in the line and completely protected. It's not like that. On the subject of SPD, there are standards 61643. There are several sub-standards. Two of these standards are adopted in IS 16413 part 1 and 2 or part 11 and 12, which is for SPD in the low voltage power line, performance requirement and selection and installation. Now, there is an interesting subject to look into. In an electrical installation consists of so many things, starting with the transformer, cables, wires, busbar trunking, panels, protective device, then meters and so many things, current using equipment. Protection from over voltage is one of the several subjects. So, if you look at from the point of view of the electrical installation, the importance given to SPD is quite less, because it consists of so many protective devices are there, and one of the protective devices SPD. Whereas if you go to the lightning protection standard, SPD is a very important subject. So as a designer, first you should understand that you are not designing an SPD or lightning protection, you are designing a building, and your building and electrical installation only need SPD. I will just go through some of the selection points so that you will be able to select and erect an SPD appropriately. There are two standards, 60364-553, which is nothing but IS 732 or NEC part 113 section 13, and 62066. This is actually surge over voltage and surge protection in low voltage AC system for basic information, how in case of a lightning on the overhead line, how much current can be coupled into the building. Those informations are given in this particular standard. 62305, this is the current structure. 62305 part 1 to 4 is the global standard. It is adopted in America as NFPA 780. Almost similar is adopted in NFPA 780. BS, the British standard, the German standard, the French standard, and all the European and all the big, developed nations adopted the same standard. So we can call as our standard is one-to-one incompatible with the international standards. But here the only confusion is Americans, once when they adopt the IEC standard, they take the principles and they sometimes try to specify specific components. For example, they will say a round is not allowed, only flat, because standards are also sometimes used to protect the market. It's a fact that the standards are not made by holistic people. Standards are made by business people. So sometimes to protect the interest, these are also made, but you can be sure that IEC standards are made in such a way that it do not push you to use a particular technology or something like that, and the patents and all those things are out of the scope of IEC. But of course, there can be some clever points that it is the intelligence of the user to find out and use it appropriately. So American standards of always, they make a little bit difference in IEC, but the principles are same. They are not supposed to violate IEC standards because they are also an IEC, signatory in the TBT agreements, technical barriers to trade agreements. Basically, lightning protection consists of 4 subjects. 62305 part 1 talks about the general subjects, part 2 risk assessment, part 3 external protection, part 4 internal protection. When it comes to project, lot of time I have seen people are asking very seriously, I want risk assessment report. Without risk assessment report, the next step is not possible. Sometimes I get a feeling that the risk assessment is going to protect the building. The risk assessment is just a paper which tells you what level you need. For that you have a table in NBC, data center level 1, the hospital level 2, something like that. There is a table, you can simply refer that. So even if you are putting level 1 or level 2, it does not make much difference. So basically, The risk assessment, of course, it is an important subject, but don't try to put that is the most important subject. I would say the most important subject is, for example, you have a building which has to exist for next 50 years or 100 years. You have to make an installation which has to exist at least for 25 years. So the selection of material, the corrosion, the tightening torque, those are much more important than the risk assessment. Now, coming back. 62305 talks about air termination, down conductors, earthing and shielding. This means a building will be protected against lightning, and if you have all these three, air termination, down conductor, earthing and shielding, if the number 4 is not available, of course your electronics will fail. Most of the building, air terminations are there, I have pictures I will show you. Then with respect to internal protection, you need to have equipotential bonding, SPDs, equipotential bonding with the help of SPDs sometime, then bonding and shielding and cable routing. Within this, the scope, lightning protection, in order to find out sometime the level of protection, sometime what kind of safety measures, or to benchmark certain requirements, lightning protection level or lightning protection zone, these concepts are also introduced in the standard. But please note that the concept of lightning protection zone, LPZ, this is a concept which is applicable not only for lightning protection, it is applicable for different cases. The same concept is put into the electrical installation, and sometimes this is called as the voltage impulse withstanding capacity of a device, voltage impulse categorization or installation category. So all these are actually interrelated. For example, some buildings which require very high level of protection from an EMP, electromagnetic pulse, there also the same principle is applied, but the values are different. So the first question which people always ask is, what is this 10 by 350 and 8 by 20? Sometime this is also a serious point of discussion. 10 by 350 is very big, and it may danger all those things. 10 by 350 is a simple current waveform. The current or the equivalent energy of lightning, a direct lightning impact, if we convert the equivalent energy into a current waveform, the current will looks like this. 10 microsecond it goes to peak and it comes to half value in 350 microseconds. It means not all the lightnings are 10 by 350. Lightning can be any value. But finally you need components, you need some systems to protect your building, and those items need to be standardized. So one company say X, another company say Y, this is not possible. Everybody should follow the same standard. As a result, the standard waveform or the energy equivalent of lightning has been fixed as 10 by 350 microseconds. In 10 microseconds, the equivalent current goes to peak and comes to half value in 350 microseconds. But sometime if we ask, does there really a 10 by 350 microseconds wave shape exist? No. It's an 8 by 20 microseconds current impulse with charge and specific energy. That means the big capacitor is discharged in a very short time for to achieve this particular figure. Now, the second wave shape is called as 8 by 20, which is we say equivalent to switching impulse or switching surge. 8 by 20 means the current, the equivalent current goes from 0 to peak in 8 microseconds, comes to half value in 20 microseconds. So these two, sometime 10 by 350, 8 by 20 is confusing you. Please note that 10 by 350 is applicable wherever direct or partial lightning current flows. If there is no chance of a lightning current flow, direct or partial lightning current, then 10 by 350 is not applicable. Then we go to the next interesting table. Most often we really seriously not look into this particular table. You see, first positive stroke, first negative impulse, first positive impulse, first negative impulse. Lightning is classified into positive strike and negative strike. Positive strike means the cloud is positive, ground is negative. Negative strike means cloud is negative, ground is positive. So it's opposite. One, probably the flow of electron is from the cloud to ground. Next flow of electrons is actually from ground to cloud. So opposite phenomena. So whatever the components which we are using, these are for lightning protection. These are technically, it should be bidirectional, because lightning can be positive or negative. Now first positive impulse, probability is 5%. I put as 5%, but the probability of positive lightning strike is much lower, less than 5%. There are still some studies going on to identify in a tropical area how much positive, how much negative. In a winter, cold area, out of 100, how many positive, negative, these things are going on. Most probably, in the tropical area, more than positive, negative lightning strikes are more, but anyway, it's an unconfirmed result. But now what is important for you is, positive impulse and negative impulses are there. Positive impulse, the maximum is about 5%, negative impulse, maximum it can come up to 95%. Out of 100 lightning strikes, 5 can be positive and 95 is negative. Then there are other chances as well, subsequent impulse. That means in a stroke, first there is an impulse followed by several impulses or several strikes, strike. So one lightning strike, sometime it can be only one shot. Sometime it can be one shot followed by several shots up to 30. Sometime there is one shot followed by a long stroke. Long stroke means the current is less, but it can flow for a longer duration. It all depends how the shape of the cloud and so many, that is a physics part of lightning protection. That is not our subject. Now, what is important for the engineer is to understand that there is positive, there is negative, first impulse and the subsequent impulse. Lightning protection is classified into 4 levels, LPL 1, 2, 3, 4. Now, you see the first parameter is the equivalent current, or the energy which is going to flow is converted into current, because we have to generate a current impulse in the laboratory to test a component. So the equivalent energy is converted as current, and you can see here level 1 where I am moving the cursor, level 1 is 200 kiloampere, level 2 is 150, level 3 and 4 is 100 kiloampere. First negative, the current itself is 100 kiloampere. So that means 95% chances, even the strongest negative, the current is 100 kiloampere. Then LPL 2 75 kiloampere, LPL 3 4 50 kiloampere. So this is the peak current. Then we have 2 more parameters, impulse charge and specific energy. Impulse charge means the charge of the cloud. Specific energy is the capacity of the cloud or capacity of the lightning current which is capable of heating up an object. You see the effect on the right side, thermal, arc, mechanical and thermal. The impulse charge and specific energy is available only in the positive impulse. This is not applicable for the negative impulse, because in order to make engineering practice, the contents are classified, current, there is charge, there is specific energy, then there is an average steepness. So impulse charge and specific energy is applicable only for the first positive strike. Average steepness, which is, I would say, as an engineer, the person who is making a lightning protection design or installing a lightning protection design, one of the most important parameter. Of course, current is also important, but this is also important. What does this says is, you see di by dt, 20, 15, 10, I am moving the cursor. Now in the second negative impulse, 100, 75, 50. di by dt is a rate of change of current. Now a current with a very high rate of change of current, high di by dt flows through a conductor, due to the impedance of the conductor, large voltage or potential is generated in the conductor. Example, 1 meter of wire, if this one, the first positive, 20 kiloampere per microsecond flows through 1 meter of wire, 1 meter simple wire, it can be 10 square mm to maybe 1000 square mm. The impedance almost same. This 1 meter wire can have a potential difference from one end to the other end, approximately 20 kV. Same way, if we look at the second one, so first negative impulse, the potential difference of 1 meter wire can go up to 100 kV, very large values. So the di by dt, or the voltage which is generated in a conductor through which the current is flowing, negative strike is very high. As a result, if imagine on this wall you have a 5 meter conductor. At the top of the conductor, the current is flowing. From top to bottom, a potential difference is created. What happens? The conductor either tried to attract the nearby metallic object, or it tried to repel. The energy, the forces are, mechanical forces are very high. That is why it is written as here mechanical force. The di by dt is trying to create mechanical forces. The current is creating mechanical forces, and the di by dt is creating lot of surges. The current tried to jump from one place to the other. Also the subsequent impulse, surges and flashes are strong. So just keep in mind that positive strike, negative strike, then 5% is positive, 95 is negative, then you have the current, the specific energy, the charge, the rate of change of current. All these matters once when you design lightning protection in your installation, because the person who is designing, he has to really look deep into the subject and he has to find out the effect. You see, finally our aim is to reduce this effect, mechanical and thermal surges and flash. Lightning protection level, there are 4 classes specified in the standard, level 1, 2, 3, 4. Level 1 is from approximately 3 kiloampere to 200 kiloampere with a probability of, for the maximum current, 99%. This means if you go for a level 1 protection, your building is protected, the probability of hitting is 1% still exists. It's not 100% protected, 99% protected. Similarly, if we go for lesser one, you see level 2 97%, level 4 84%. These are the probabilities and these are the currents. 2.9 to 200 kiloampere in level 1, 5.4 to 150, 10 to 100, 15.7 to 100. These are the current range. I know that after lunch, this is a nice subject to discuss. I am standing here and singing a song. Yeah, but I will put some bomb in between. Okay, now the first job of, with respect to protection, the first job is to create an air termination system. Air termination system means something at the top of the building in order to intercept the lightning. Means the lightning shall not come and hit your building. Instead, it has to hit the material which we have placed at the top, maybe a ring or a rod or whatever. I just show you a mesh, let's say for example a grid. Then all the metallic items at the roof must be bonded to the air termination grid. Let's say you have a chiller, you have maybe some ladder, or you have an antenna, or you have some pipe. All these metallic objects must be connected or bonded to the lightning protection air termination grid. I just put an example. There are 2 techniques here. One is you isolate the lightning protection. Second technique is you bond. Isolation is sometimes applied in certain places, bonding is applied in certain places. Let us think that I am going with the principle of bonding. This means all metallic parts at the roof must be bonded to air termination system. Example, let us say air termination grid 15 meter by 15 meter, we are going for a level 3. Few rod to protect the roof mounted AC unit is also required. Equipotential bonding with air conditioner and solar PV, if these are there, we have to make. We can also apply the technique called as rolling sphere method, electrogeometric sphere, to find out the probable place of lightning strike. Then we have to have several down conductors, for example 10 down conductors, maybe 5 down conductors, 20 down conductors. Depending upon the size of the building, you have to have multiple down conductors. Each of the down conductor has to be connected to an earth termination system. At the bottom I'm sure you are able to see the cursor. So here we need to have a earth electrode for each of the down conductor. This is called as type A earthing, type A. Then the fourth subject is the down conductor must be connected to the protective equipotential bonding of your building. Means at the mains incoming, you have an earth bus bar, the down conductor must be connected to the earth bus bar, and you also supposed to, or you are also supposed to put devices called as SPD, surge protection device, in these switchboards. Now, you have 10 different metallic objects, like one service is going to the street light, another going to maybe something else. So if 10 wires are going out of your building, all the 10 wires you are supposed to put SPDs and make this kind of bonding. One of the problem, once when we go to inspect a lightning protection system, 99% of the installations, this kind of equipotential bonding, that means the down conductor bonded to the earth bus bar, is it existing or not? 99% exist. Can you raise the hand? 99% don't exist. Yes. So most of the time lightning protection is done for the namesake, because somebody is asking, the electrical inspector will ask where is it, so just to show him something there and some conductor. So if this actually it won't work. So if you wanted to have, my idea is to explain you, this is what is written in the standard and this is what we are supposed to follow. If you don't follow, you don't get protection. It's none of, I have no issue. It's up to you to make bonding or no bonding. Now, in the earthing part, you can also make an earthing system called as type B earthing, means a ring all around the building. These are the main components of lightning protection system. Now with respect to air termination, there are 3 techniques which is applied for finding out or making a air termination system. The first one is a mesh method. Here the mesh at the roof, if you have a flat roof, you make a mesh and the mesh size are specified in the standard. You simply make a mesh according to this size. You don't need to do anything other than this if there is nothing above the this particular grid. The second method is protection angle method, means sometime you may use an object which is taller, a tall object, and these tall objects offer certain angle of protection. Depending upon the lightning protection level, we can calculate the angle of protection based on this particular table. These tables are also already in the standard. The third method is called as rolling sphere method. It is also called as electrogeometric method. So this method also can be used for designing, or this method can be used to find out the probable place of lightning strike. The first two is made with a material, a ring, or say for example a grid. Grid is made with a material. The rod or something vertical means some material, whereas electrogeometric sphere, the rolling sphere, is not a material, it's a technique which is used to design the air termination system. Why I am stressing this point is, there was a few years back, one of the customer told, I want lightning protection as per rolling sphere. Then I told, I cannot bring a sphere to place. Then he was so specific, I want sphere. I want a spear, to protect. Actually, he was confused with the ESE and this conventional. So he thought we are going with some ball to put on the roof. It's not like that. So this is not a device. It is a technique with which we can find out the probable place of lightning strike. The second subject is down conductor. Down conductor, again depending upon the level of protection, 10, 10, 15, 20. Several down conductors are required. The distance between the down conductors are specified in the standard. But also you should understand that down conductors must be outside the building. In NBC we have specifically written down conductors shall not be routed through any shaft. But sometime we see surprise that architect don't want to show lightning because down conductor is dirty. I don't want to show it in my building, so put a shaft from top to bottom. Then they say, you have 20 down conductors, I provided 4 shaft. So 5 numbers you take on this side, 5 numbers 1 meter away there is one more shaft, 5 numbers here, 5 numbers on the other side. This is a violation, it won't work. So down conductors has to be placed all around the building. There are some conditions. For example, one side of the building you cannot route the down conductor. Then there is some there is some relaxation given. Instead of one side, you place it on the other side. Some techniques are there. But otherwise it has to be outside the building, throughout the perimeter of the building, straight without bend if possible. As I said, the negative lightning strike, which is having a very high di by dt, rate of change of current, the amount of potential which is going to create in this conductor is very high. If you have a bend, a small bend is equal to 1 meter wire. A full coil is equal to maybe 5 meter wire. That much potential is created. All these places will be exploded. So you cannot expect. So the max, as much as possible, the conductor has to be straight, not through shaft. Safety distance need to be maintained to avoid flashover. I will come to this point later on. Then we go to earthing. Each of these down conductor need to have an earth electrode. For example, type A earth electrode, there are two categories, type A and type B. Type A consists of two types, vertical or horizontal. Type B consists of a ring or a mesh. So these four techniques can be used. Out of these four techniques, the type A is, you can use it for a normal building, for example a house. Whereas for a place where electronics is involved, a lot of electronics is involved, you need to go for a type B earthing, or the last one, foundation mesh as a closed loop, ring or closed loop. This is also written in the standard. If you have an electronic installation, you go for a type B earthing. Even though this is written in the standard, example, most of the data centers, in Bombay, there are so many data centers. Most of the data centers, they have 20 earth pit, 40, 50 earth pit, so many down conductors. But unfortunately, 10 numbers routed through one shaft. Then these 10 numbers have 10 different earth pit. So this is actually waste of money. It is not going to work. Even if you avoid it, the result will be same. Basically, for places where you have electronics, you are supposed to have a foundation mesh or ring earth. Okay, I have put here, type B is for buildings with electronics, high-rise buildings and explosive areas. Type A, not only vertical, please note, horizontal is also possible. One of the simple technique which can be adopted is, the standard gives you a table. Depending upon the soil resistivity, you can take the table and you can select the length of the wire, the length of the vertical or horizontal conductor. Say for example, horizontal conductor 8 meter. So you put an 8 meter conductor and leave it. So in that condition, you don't need to measure the earth pit resistance as well. You don't need to. You put that conductor 8 meter horizontal. Maybe in another condition it is 5 meter, another condition it may be 20 meter, depending upon the soil resistivity. So now if you are not maintaining this distance, you can put a 8 meter conductor, but of course you don't have 8 meter space. In that condition, you make something, then you measure the resistance and ensure that the resistance is lesser than 10 ohm. That is how it is. Ring. The best way is to make a ring all around the building, which is called as type B earthing. Ring earthing means a ring, please note, ring is closed. It is not an open. If it is an open, if you didn't connect it 100%, then you have to treat it as a type A earthing. You cannot treat it as a type B earthing. So now it has to be a closed loop. All down conductors shall be connected to this ring, and preferably this ring is 1 meter away from the building, 0.5 meter below the soil. The mean radius R of the ring shall be greater than this particular calculation. There is a small calculation also we have to do. Say for example, there is a table in the standard which I didn't show. Let me see. Yes, I have this particular table. This is the table. First we have to find out the constant L. Let's say for example, you are going for in Hyderabad, the soil resistivity is let's say 1500 ohm meter, level 1. That means the L is something about 30 or 35. Now, you apply the technique type B earthing. Now you have to find out the mean radius of this ring, and this mean radius of this ring must be greater than 35. So this calculation is also done, also have to be done. No, this is type A ring, we are only talking ring, that is the next one. Then this type of arrangement comprises of either a ring conductor external to the structure to be protected in contact with soil. The last type of ring earthing is called as foundation earthing. Foundation earthing means a grid which can be in the soil or inside concrete if the concrete is in touch with the soil. It can be used as a type B earthing. The most efficient way is type B earthing. So just an example, you can find this picture in NBC, NEC and all the, not NEC sorry, NBC and ISIC 62305. One of the technique which is included or it is going to come in the new standards, I think this is also included in the NBC, protection of people outside the building, because during lightning strike, if people are outside the building, they can be, due to step voltage, people can be injured, and if you make this kind of additional ring, extended ring in soil, we can protect people from step voltages. Now we go to another interesting subject of lightning protection, which is, you see here, there is a building. First, we are making the air termination, down conductor, earthing, equipotential bonding and SPD. All these are pakka. You have a grid at the top, you have 10 down conductors outside the building, you have maybe an 10 earth electrodes, and you have an equipotential bonding. One important subject which also need to be considered is called as separation distance. The idea behind the separation distance is, now imagine the lightning is striking this place, the lightning is striking the air termination. As I said, the di by dt, rate of change of current, what happens is, once when the current flows through this particular conductor, a very high potential is created in this conductor. That means during that momentary time, this part of the air termination and this part of the down conductor shall have a very high potential difference. Now where this potential difference will be applicable, for example, you have an internal wiring, let us say there is a wiring inside the building, there is a wiring. So this wiring at this place where I have put the box, the round there, the air terminal which is just outside the building and the wiring inside the building will experience a high potential difference. There will be a direct flashover. So lightning has struck your conductor, but from the conductor inside your building there is a flashover. The result is the lightning now you have captured inside. The lightning has happened inside your building. This kind of flashover can happen to any apparatus, any metallic installations. Any metallic installation in the sense, in order to avoid this flashover, we are supposed to have a electrical separation. You have to either bond or you have to separate. Bonding means the conductor which is inside the building and the air termination outside the building must be bonded, but you cannot do it every time. So you have to separate it, for example. Separation distance required at top floor between electrical wiring, metal frames, RCC from the down conductor with equipotential bonding at the ground floor. Now we make a small calculation. This calculation is available in the standard. So this is the separation distance required. Now a building which is very well protected with separation distance, it will look like this. You have a building, the air termination has to be gradually away from the building. At the top, you have to keep the separation distance. Example, the calculation says 1 meter means your air termination grid and the down conductor at the top has to be 1 meter physically away from the building. Is it possible to make a lightning protection half meter away from the building? Technically not possible. This also means that in high-rise buildings, if we make a lightning protection without calculating the separation distance, again it is to show the authority. Practically, once when there is a lightning strike, the result you know very well. Now, You need a separation distance from frame of structural, steel, electrical wiring, rebar, metal doors, metal windows. I just try to calculate an example. Let us say an RCC building with the external lightning protection system. We have selected lightning protection level 2. Height of the building is 35 meters, maybe 10 floors building, a building with 10 floors. Length 30 meters, width 25 meters, 10 floors, 3.5 meters each. I just put the calculation. The first calculation is made with equipotential bonding at the bottom. With equipotential bonding at the bottom. So these are the calculations. Now, here the constant values, there are tables given in the standard. You have to take up the appropriate values and you have to multiply, calculate it. And if we calculate in this particular case, S equals 0.924 meter insulation air, means between the air terminal and the building, if you are calculating the insulating material as air, you need 1 meter separation, 0.924 separation. If you are calculating brick, then you need almost 1.84 meters separation. That means your air termination physically has to be 2 meters away from the building. This is with equipotential bonding. See here at the bottom, there is an equipotential bonding here. Now, without equipotential bonding, technically you cannot calculate this because the distance required may be infinity. Infinity in the sense, technically your system will not work. Lightning will strike the air termination, but there will be flashover into your building if you don't make equipotential bonding. So, in an unknown condition, we can say that instead of 1 meter or 2 meter in the previous case, this may be 10 meters. So you have to keep you have to make another structure to keep your air termination and down conductor. Practically this is not possible. So basically from this what you have to understand is, for high rise buildings or buildings with more than 15-20 meters height, making an air termination without touching the building or making an isolated air termination system and down conductor and everything, this is, you forget, it is practically not possible. Now, I also made some calculations with the lightning protection level 1, then the values are even higher. Now, you know very well, keeping even half meter away from the building is impossible, as you agreed. Does anybody disagree on this? Not possible, practically not possible. You can have an high voltage insulator, put 1 meter insulator and above that you make the air termination, which is, then it looks odd. So then this is a serious subject which every designer should consider in your design. I think mostly my song is quite beautiful, it looks like. Can I ask a question? Like I asked yesterday, how many buildings, these high-rise buildings, this is calculated and implemented? None. Buildings? None. Buildings with external protection, this kind of external protection. None. None. How many? 99? 90? 80? Yeah. So, see, basically you must understand that in our electrical design, there are huge scope for improvement. Not only lightning protection, even from the basic electrical safety onwards, so many things are there to improve. So we have to constantly upgrade our knowledge probably for next 2 years. We have to study a lot and this has to be implemented in our buildings. Otherwise, if you wanted to make external lightning protection for a 20-floor building like this without equipotential, why do you make it? Don't do it. Lightning will strike and something will fail. Even with the lightning protection, it is going to happen. So, this is how it is. Please. Yes. To the architect. You rightly said, sir. Because by the time electrical consultant get the drawing, half of the building is already over. So I don't know how we can take it up to the architect. I have some simple techniques which I will tell you in the end of this end of this presentation. Yeah. Now, also one more. This also means that if you are thinking about lightning protection, there are solutions are there. The problem is whether we are able to implement or not. Another technique which you, or another safety measure which you have to always keep in mind is if you are making an isolated or external lightning protection, there are chances that people, those who are in the vicinity, may be touching the down conductor and get electrocuted. So there is a minimum distance. There are some conditions, for example, under normal operation condition, there are no persons within 3 meters from the down conductor, or you put a board and ensure that nobody is going near to this particular down conductor, or your system shall have more than 10 down conductors, or the contact resistance shall be this more than 100 kilo ohm. You also have to implement some measures to reduce the step voltage. One of the technique which can be implemented for avoiding this problem is the last 2-3 meters where a person can touch, you insulate this particular conductor. There are conductors, copper conductors available with which can withstand 100 kV impulse. So last 3 meters you put this particular conductor. As a result, this problem can be avoided. Now, solution to this particular, especially high-rise buildings or buildings with steel. 62305 standard clause 6.3.1 says, in structure with metallic or electrically continuous connected reinforced concrete framework, a separation distance is not required. In structure with metallic or electrically continuous connected reinforced concrete, separation distance is not required. So you have to ensure that your steel is connected properly, number one. Now, use of natural component. Natural components made of conductive material which always remain on the structure and will not be modified may be used as part of an LPS. We will look into these two clauses and explain or try to find out what exactly is this. So for high-rise buildings, by rule, most of the developed nations, by rule, they have already made regulation saying that you are not supposed to take an external down conductor. If you are taking, then every 5 meters you have to have a ring interconnecting. That's a big process. Believe me, it's not possible. Now, the simple method is you can route your down conductor through the column, which we generally call as structural lightning protection or whatever, some names, but the name which is there in the standard is using natural component. Means you already have some steel material in the building construction. You ensure that those materials are strong enough to handle lightning current. So while construction, you make it stronger. As a result, the subject is achieved. In the standard, you can find this kind of a picture with these explanations, air termination, mesh conductors and all. Basically, what we are doing is, the air terminal which is at the top of the building is connected to the rebar, and now your structure is made as a down conductor. Now you should also look at the item number 4, mesh conductors superimposed on the reinforcement. There are different techniques used in order to make it. The first one is people try to ask, why I have a rebar, why don't I use the rebar alone? But the standard says, preferably you use a conductor with a smooth surface. Rebar, the surface is not smooth, so better you go for an additional conductor. Then the second condition is whether this conductor, is it aluminum? Not possible, because aluminum cannot be put inside concrete. Then whether it is MS, of course, for lightning protection, MS is allowed. But most often, not only for lightning protection, there are other applications as well. For example, electrical installation. More than electrical installation, you have the BMS and functional earthing requirements. Means for the electronics to operate, you need to have a good earthing system. For that purpose, whether the requirements of the functional earthing can be met with by putting a MS conductor inside? No, not possible. For example, we have I have some experience. Some of the buildings, customers were asking to install MS conductor, but if you put the MS conductor, lightning protection standard says the continuity resistance has to be lesser than 200 milliohm. That is possible. But if, as a, if I look at the functional point of view, sometime it says 20 milliohm. In some case, because you have some communication system, 20 milliohm. That is not possible. So that means you cannot use this conductor which is put inside the concrete for the purpose of functional purpose. So functional purpose varies depending upon lot of parameters, type of your communication, then I don't want to explain much into it. Now, basically, by putting an additional conductor through the concrete, when can you do it? During the casting of the slab or during the casting of the steel. After construction, you cannot make it. Now you make this red color line is nothing but, you imagine you have put something inside which is bonded very tight into the rebars, and now you are achieving 200 milliohm insulation, the continuity resistance from top to bottom. Then this installation or this conductor which is inside the concrete is capable of handling down conductor. Under this condition, separation distance is not applicable. Why? Because you have enormous amount of conductors in this building. The current is entirely flowing over the building, on the slab, on the roof, throughout the building it is flowing. The result, the effect of this, you are making a Faraday cage. The effect inside is quite less. So this is how it is. Nothing exposed, do not affect aesthetics of the building, most efficient for electronics. So this system, of course, as we know, architect, by the time electrical consultant is, electrical designer is involved, half of the building is already done. It won't work. So the important parameter here is the continuity resistance. 200 milliohm is the continuity resistance with a test current, a meter with test current of 10 amps you should apply and test. So these are basically about, this is the last slide about the external lightning protection system. External lightning protection system is to protect your structure, the structure, overall structure of the building. Yes, sir.
Only one question. That point number 2, metal covering of the roof parapet.
Yeah.
That is a must?
No, it is actually a technique which is used in European countries. European nations or building with, say for example, this aluminum facade and glass facade. So in that case, one technique is you cover the entire portion with some kind of metal cover. Actually, that is not for lightning protection. That is for leakage point of view, but that is used for lightning protection. Joint or an angle, this point number 6. Yes, actually lightning protection standard do not explain about the technical requirements of that particular joint. There we have to refer something else. Lightning protection standard explains how you can achieve the lightning protection. Now if you wanted to bond this, for example item number 6, you have an electrical panel. Electrical panel, not only lightning, you have so many other things. For example, you have a rack or you have a switch, communication switch. Communication switch at the 10th floor and something at the ground floor or vice versa. So these item has to communicate. So their additional requirements are also there. So it depends. If you are thinking only lightning protection system, yes, do it. But if you also wanted to have integrate your communication, efficient communication system, as I said yesterday, communication system can be made in 3 ways. One is, as soon as you scan the barcode, the reading has come on the screen. Then second case, you screen the barcode after 5, once when you start counting 1, 2, then it has come. The third case, you can count 10, then only the communication is happening. So it all depends the efficiency of the system which you want. Of course, for the purpose of equipotential bonding, you need to have a connection, but again, please note the requirement, technical requirements of this bonding is not covered in the lightning protection point of view, the lightning protection standards, for example. So then we have the internal protection. For the purpose of protecting electronics inside the building, the building is categorized into lightning protection zones, LPZ 1, 2, 3, 4. LPZ 0, which is outside, LPZ 1 means internal to the building, which is protected against direct current, lightning current will not flow in LPZ 1. LPZ 2 is further reduced, or the effect is further reduced, and LPZ 3. Like that, zonal protection methods are implemented in the standard. Each of this zone, it has to have certain, technical requirements. Now, once when a power line or once when a metallic service passes from one zone to the other zone, let's say for example, there is a power line, the power line is passing from outside to zone 1, zone 2, zone 3, which is further going into the building. At every zonal interface, you are supposed to make an equipotential bonding. With respect to electrical safety point of view, the first equipotential bonding we can call as main protective equipotential bonding. The second one is supplementary equipotential bonding, and something like that. So basically, you need to have SPDs in these areas. These areas are nothing but, the first one is main distribution board, sub distribution board, and probably very closer to your socket. Now, more than using the right things, we always try to read the standard, as I was mentioning, we read the standard to find out how can we escape, not to follow. Europeans and Americans read the standard to follow it, how best they can follow. We read it how best we can come out of it. So, this. Now, with respect to lightning protection, there are two kind of non-standard system available. IS IEC 62305 says you have a rod and the rod have certain angle of protection. There is a technique called early streamer emission. I think some of you are already know. There is an NBC, this item is banned. There is a court case. I was also put along with the BIS as a party to the case. So I was running behind this case, appointing lawyer and all. Now anyway, because thanks to CEA regulation has made NBC mandatory. So this item is gone. Now, and ESE says one rod protect 100 meters, for example. Means you protect yourself and you protect all your neighbors. You are, such a wonderful person. You put your rod and all your neighbors are protected. A very nice story. The second concept says you are, the same, you protect all your neighbors, but the principle is opposite. The first principle looks like an umbrella protecting, lightning. The second looks like an umbrella which is opposite. So whatever coming is collected and put to, one rod. And the next technique is even more interesting, which says a lightning eliminating system. If you put this particular, the third one, the manufacturer says this one, originally this item, lightning elimination, it has come in 1973 or 1975. Originally the manufacturer says, if you put my rod, it dissipate the cloud. If you look up, the cloud itself is gone. Then what is the chance of no lightning? So this story was explained in the beginning. Later, there was big objection, and within 2 years, people started objecting. Then this gentleman cleverly changed his definition. What he told is, it is not dissipating the cloud. It is dissipating, once when the lightning stepped leader comes towards your house, it is looking on your house. As soon as it reaches, this rod will reject it and the lightning will go to your neighbor's building. That means you are an enemy to your neighbor. So something like this, you see, it diverts the lightning to your neighbor. So like this, lightning protection is a subject which is more than the fact, lot of stories are running around. And always the stories are fascinating. One rod protecting 100 meters, something like this, and always these ESE, the non-standard manufacturers, the story is quite interesting. People are very much attracted towards the story. Advanced technology, modern technology, latest technology, digital technology, whatever the fascinating names, maybe internet, IoT technology, all these, the names, fascinating names are added to this particular device. And 100+ meter lightning counter. Sometimes engineers don't believe it. Because these, after 2 meetings, you know that this looks like a story. Then engineers ask, no, I don't believe you. You show me the proof. Then these companies will come with a proof. They say that there is a standard, NFC 17102. It's a French standard. Look, if French people can accept it in their standard, what is your problem? French people are also intelligent. Then we think, right, French people, they are intelligent, and if they can use 100 meter, why can't we? So then what we do? We buy it and install it. We never try to read what is written in the French code. We never try to read what is written in the French code. That is the problem. Now, how the French code is made, you see here, this picture you can see in the French code. In the French code, you leave the item number 1. Item number 1 is the air termination, the ESE rod. The serial number 2 to 18 is nothing but our Indian lightning protection, the conventional ISIEC 62305. So what the French code says is, indirectly, you make a Pakka lightning protection system, over and above you put a rod. Now this rod is protecting you and 100 meters all around. I hope you understood, right? You protect your building Pakka, because 62305 is mandatory in France for certain size of buildings. You protect your building with 62305 techniques. Over and above you put a rod. Yes. So I always say that NFC 102, 17102, of course it works if you make lightning protection 100% as per this. But what is told in the Indian market? You have one rod, one down conductor and one earth electrode. Lightning will hit the rod and the current will flow like water flowing through a pipe and it goes to the soil. This story is absolutely wrong. So please understand it and try to follow. Now, how the installations are carried out in India, you can find this kind of installation in several places, because the building is constructed, of course the tender is made along with the civil, but nobody took care of it, and later they wanted to install lightning protection system. You can see all the down conductors are running through one side. See this, these are the down conductors. Nice installation. And the funny part is, this is a DMRC building. DMRC, in the tender itself they have mentioned all the installation lightning protection shall be aesthetically good. Aesthetically impressive. And this is the aesthetically impressive installation. Now, so these are some of the facts. I can show you a lot of such installations. I don't want to, but please note that down conductors has to be equally placed all around the building. If you make a compromise, better you don't do in lightning protection. It is not going to work. You buy something, then you force the vendor to route 10 down conductors like this, and after some time there is a lightning and something failed, call the vendor, your lightning protection failed. Actually, not the vendor's system failed, the design is the failure. Now, material selection, very important. For lightning protection system, we use metals. Sometimes the metal is outside the building, in air. Sometimes the metal is inside concrete. Sometimes the metal is in soil. This materials has to be selected in such a way that the first point which you should understand is the electrochemical phenomena, electrochemical corrosion and electrochemical process. Now, each of the metal surface has got a certain electrochemical potential. Now, gold, the best, then it starts having the potential. Gold is ideal situation, platinum or gold, then the potential starts building up. Now, there is an Indian standard already available. You can look into it. Always for my reference, I try to take from this particular book. This is from a book, one of the world famous book from Mr. Rudolf Willem. He was the chairman of IEC TC64 and IEC TC81. He was working in IEC for a long time, and he has made this, because since beginning of the IEC 60364, he was involved in the standards making. So he has got a lot of experience. In his book, he explained, for example, how protective equipotential bonding, it started. Actually, I show you a picture with, MET connections and all. I got this picture from CPWD manual. And then I was searching, found out a gentleman who has retired a few decades back. Then from him, he told me that there is a book written by somebody from Germany, and then he gave me a photograph and I bought this book. So big history. Now this book explains very well, one of the chapters is about electrochemical potential. Now, what this book says is there is a table which shows the electrochemical potentials of different metals in conditions like in air, in concrete, in soil and so on. Now, if you have two different metals in a media, it's like a battery. So, one is having one potential, the other is having a different potential, then there is a current flow and the corrosion process starts. Now, this is also explained a little bit in IS 3043, not very well. For example, here you have the foundation. This picture is from his book, figure 54.8. This is the foundation, and here you have the steel pipe, and here you have an earth electrode, earth rod in soil. You can see the arrows which is shown. There is a current flow. A DC current between anode and cathode in electrolyte result from the influence of potential difference of the galvanic cell formed by different materials of the earth electrode by the electrolyte of moisture content of the soil and through the bonding of anodic and cathodic earth electrodes. With the anodic range, the current leaves the surface of the electrode towards the electrolyte, thus dissolving the metal of the anode. That means the anode is dissolved. You know the meaning of dissolved. Dissolved means dissolved. After a few months, if you see, nothing exists there. You cannot, because it's dissolved already. Now, this current enters the metallic surface of the electrode in the cathodic area. The electrolytic current passes losses of mass of the anodic earth electrode, means the weight of the item is lost and it's gone after some time. The speed of the metallic loss depends mainly on the voltage of the galvanic cell. That means selection of this material is very critical once when you make a lightning protection system, because sometime you use material inside concrete, sometime you use material in in soil. So if you have a metal inside concrete and outside concrete, means in soil, you have to be particularly very, very careful. Now let us look at what is written in the, I don't want to explain this one much. Or this one, the first one is important. Interconnection of all earth electrodes for a different purpose with other earthed construction is recommended for increased electrical safety. That means interconnection of earth electrodes is recommended for safety. Electrical isolation of various electrode is no solution for protection of the electrode against corrosive effect. The only reliable solution is correct selection and installation of electrode. Now let me show you what is written in the standard. So this one, selection of material for, I also put the word structural earthing, the correct word is natural component, clause number E 4.3.4. The following material can be used as additional conductor, look, additional conductor, installed in concrete for lightning protection purpose, steel, MS, GI, SS, copper or copper coated steel. All these metals are possible inside the concrete. Now you read the next line. The behavior of galvanized layer in steel in concrete is very complicated. I don't know how much complicated it is, because I could not find out any further research papers on it. Of course, lot of research papers are there. It is better not to read, because then we see within 2-3 years, for example, you have a high-rise building at the, let us say at the 30th floor, maybe there is some pipe leakage or little bit leakage which is making that area wet, and there is inside your pillar there is a GI strip running. Due to some water leak, maybe from the toilet, this area is wet. You know what happens? This the zinc coating, it expands. As a result, after a few years, after 3-4 years, the concrete is broken. You can find out cracks. First the cracks will appear not on the wall but on the pillar, and after some time it's a problem. Now, particularly in concrete with chlorides, the zinc will corrode quickly in contact with reinforcement and can under certain condition cause damage to the concrete. Not only in wet condition, even if it is in dry condition, zinc can create a problem, create a, corrode in quickly if it is in contact with soil. As use of galvanized steel in concrete requires evaluation of many external factors, this material should be used only after careful analysis. So you have to, if you are using GI inside concrete, you can use it, nobody stops you, but you have to use it after careful analysis. Now, can I ask how many of us know to make this analysis? How many of us are sure that at the 30th floor there is no leakage after 5 years? Really, we don't know. So it's risky. If you are interested in a building for a long life, or if you are interested in the life of your building, it is risky to use. Now, in order to avoid confusion between different type of steel rod in concrete, it is recommended that round steel rod of at least 8 mm diameter with smooth surface to be used as additional conductor. So these recommendations you can find in the standard. I am not going through all the recommendations, only few. Then the other one, you see, the clause of E 5.4.3.2, a further problem arises from electrochemical corrosion due to galvanic current. So this is the previous one was about galvanized steel inside concrete. Now this is talking about galvanic effect between two metal parts. Now steel in concrete has approximately the same galvanic potential in the electrochemical series as copper in soil. That means steel in concrete and copper in soil are having same potential. Steel inside concrete and copper in the soil are having same potential. That means it may not corrode. If you are connecting copper in the soil with steel reinforcement, no corrosion. That is the meaning. Therefore, when steel in concrete is connected to steel in soil, please note, when steel in concrete is connected to steel in soil, a driving galvanic voltage of approximately 1 volt causes a corrosion current to flow through the soil and the wet concrete and dissolve steel in soil. So what this part says is, imagine this podium is the metal structure which is having the steel reinforcement, or you did something. Now you have something in the soil, outside or maybe under the building, you have a grid, and that grid is made of galvanized steel. Please note, in galvanized steel, the galvanic coating is called as protective coating. The galvanic surface will corrode, it will dissolve first. Now you have GI strip maybe in the soil nearby or under the building. What happens? You have connected both the steel inside concrete and the steel in soil. The GI in soil will, after 2 months, it simply disappears. It corrodes. But the problem is, you have a building which has to work for next maybe 100 years, and you put a galvanized steel strip under the building. Now you don't know whether it exists or not. So what the standard says, earth electrode in soil should use copper coated steel or stainless steel conductor where these are connected to steel in concrete. If you use something in soil which is connected to the concrete, so you use copper, stainless steel or copper bonded steel. So this means galvanic corrosion between steel in RCC and steel in soil, the steel in soil will be dissolved. Actually, if we look at a lot of buildings nowadays, the method structural earthing or lightning protection is carried out. But most of the installations, galvanized steel is used in soil, and exactly this, whatever is written not to use has been used. What happens, after few years there can be spark over and fire in several places. There is no guarantee. Now the further explanations of this can be found in several places. For example, the next clause, galvanized steel with earth electrode in soil should be connected to the steel reinforcement in concrete by isolating spar gap. This part what says is, if you are, due to some reason, you have some galvanized steel in soil, don't connect it directly to the steel in concrete. You use a spar gap in between. But if you use a spar gap in between, that means technically these two are isolated. You are not bonding it. So your safety is lost. A direct connection in soil would significantly increase the risk of corrosion. So all these are explained in the standard. Now let us go to the second part, the SPD. I am not going, I have only 2 more slides, I will finish quickly. SPDs, as I told, depending upon the zonal concept, we are supposed to use the SPD. The first point which you have to be very careful while selecting an SPD is, once when you connect an SPD, you have to use a very, very short wire for this connection. The maximum allowed length, for example, A means from the bus bar to the SPD, from the SPD to the bus bar, A plus B is maximum half meter. That means top probably 250 mm, bottom 250 mm, or top 400 mm, bottom 100 millimeters. So you have to make this connection with a short wire. Most of the time, there are panel builders, those who are buying SPDs, and they try to connect it with 5 meter wire. What is recommended is 0.5 meter, but actually 5 meter wire is used to make this connection, and then everybody believe that this SPD will protect. Impossible. So this kind of this connection is also recommended. The subject is further explained in the standard as effective protection level. Means if you make the connection through a wire, as I said, once when the lightning current flows through a wire, high potential difference is created on the wire. Now our idea is to reduce the impulse voltage potential difference between 2 metallic parts, maybe phase and the neutral. But we have a long wire, this long wire is increasing the potential, effective protection level is gone. The second safety measure which you should always keep in mind is, especially these two are applicable for power line, 230, 400 volt line, backup protection. People always try to, the type 2 SPDs. Type 2 SPDs are bought into the panel, and the manufacturer says up to 125 amps backup fuse is not required. So as a result, what happens? Yes, we buy and put the incoming breaker is 125 amps, and the SPD is connected without any backup protection. In that condition, no backup fuse is, it means the SPD, once when it fails, it is able to handle certain amount of short circuit current. Now, the IS 732 or National Electrical Code has classified 2 type of protection. First one is this one. See, you have a backup fuse and you have an SPD. In the second case, you have a backup fuse and you have one more SPD. Now, in the first case, if this SPD fails, this backup fuse also will fail. That means continuity of supply is lost. In the second case, you have still the 125 amps, but you have used a 63 amps additional fuse here. Once when the SPD is short circuited, the additional F2 has disconnected the SPD from the line. So this one is called as continuity of supply. The first one is continuity of protection, second one is continuity of supply. So the question an electrical installer, a panel or the installation designer, a designer should think is what you need, continuity of supply or continuity of protection. Based on that, you should select the HRC, the backup fuse. 2 type of connections are, I have only 2 more slides. 2 type of connections are included in the standard. The first one is called a CT1. 4 current carrying conductors, 4 SPDs directly connected to the earth. Here CT2, 3 numbers from line to neutral and 1 between line and neutral and earth. Actually, once when you look at the lightning, the transient is a common mode phenomena. So this kind of connection is better for the type 1 SPD, which is at the mains incoming panel. Whereas for the SPD inside the sub distribution or near to the equipment, you can go for CT1 or CT2. At the mains incoming, the best way is to have the 4+0 or CT1 connection. The NEC also had shown some pictures in section 13, something like this. This is actually to calculate the risk assessment or make a risk assessment, whether you need an SPD or not, and what is the rating of the current rating of this SPD, because this is actually a problem in the market. Once when we go to a customer, customers always feel that 20 kiloampere SPD is, no, it's not enough. I want a 100 kiloampere. And somebody says, I want a 200 kiloampere, 400 kiloampere, 600 kiloampere. People just think that if you increase the current rating of the SPD, you get, very good protection. It is not like that. Current, the intensity of current is maximum something. It cannot cross beyond certain limit. You have to find out you have to make the risk assessment. For example, in this case, you see the CRL, if it is less than 1000, no protection against transient overvoltage of atmospheric origin is needed. You don't need any SPD. So these informations are also given. In the Annexure D, Part 1, Section 13, you can find out the maximum impulse current required for the SPDs at the main distribution board, sub-distribution board. Annexure D, Table D2 explains something more. So you can easily select the current rating of the SPDs through these particular tables. So this is the end of my presentation. Thank you very much. Now, before ending, I have 2-3 more slides. The idea is we are going to have a panel discussion. So like yesterday, I was making a platform for the discussion. Now to make the next platform for discussion before tea, I have 2-3 slides just to find out the subject is compliance and non-compliance. Would be very nice to discuss. I just would like to show you what are the new regulations and standards going to come. Now, you know very well, we had a nice discussion in the morning. Class 5 copper wire is non-compliance. You can very soon find it out, probably once when the electrical inspectorate engineers are aware of it, or the electrical safety auditors are aware of it, they will, or the insurance companies are aware of it, then they will start insisting for class 2 copper wire. This is very well given. In the Part 1, Section 17, Table Annexure B, the resistance of the conductors are given for 30 degrees centigrade, and the calculation for other temperatures are also given. The next mandatory requirement is a different type of RCDs for your installation. Regulation number 44, the earlier, regulation number 44, this is wrong, it is not 43, 44. Residual current device, I explained it yesterday once. The first para of the regulation says every installation you need an RCD of 30 milliampere. The second para says if you have a TN system, then RCD is not required. So that means RCD is becoming mandatory. Now the code, the Central Electricity Authority measures relating to safety and electric supply also says you should follow, NEC is mandatory. If you read the NEC, you should select the RCD depending upon your load. There are 4 type of RCDs, type AC, A, F, D, sorry B. For customers or for installations where you have a rooftop solar installation, you have to use a type B RCD. It is not just like the RCD available in the market, you have to use the appropriate RCD. The first confusion will be these RCDs are at the moment not available in the market. So this is there in the NEC. AFDD is also specified. At the moment it's risky. That means for the manufacturers of these RCDs and the AFDD, a new market is opening up. Actually, it would be nice to have one of such manufacturer in this platform to discuss or to explain what exactly these devices are. Any of our Krish explained it very well, but still, there is a good opportunity for them. Then I would like to show you some interesting pictures which will be, this is non-compliance. If you make this, you get a red seal. If you make like this, you get a red seal. Because these are very specifically written. This is also a red seal. This is the good one. Where these are, then sometime customer asks, lightning protection, earth separate. Of course, these clauses are already included and you also get a red seal. Then protective equipotential bonding, the regulation number 43, clause number 5 has written, every building shall have protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per IS 3043, IS 732. So, and this picture is also there in the NBC. So if this protective yesterday I asked a question, out of how many buildings or how many percentage of buildings in Chennai this safety measure, the first safety measure is implemented, we got an answer, 0%. So then you get, this will be a red seal. non-compliance. The fault loop impedance values are included. Now, please look at very carefully regulation number 43. These are the 3 points. It has got 3 points to explain. Earth fault loop impedance shall be tested to ensure automatic disconnection of the protective device and record every earth fault result thereof shall be kept by the supplier. Supplier is the DISCOM. So the DISCOM has to measure fault loop impedance and he has to keep the record for 2 years. This is to ensure that his fuse is rated properly and that is capable of disconnection. Number 2, earth fault loop impedance of each circuit shall be limited to a value. Now, earth fault loop impedance of each circuit belongs to the user. So the user of the building, the owner of the building also should measure fault loop impedance inside the building. So the supplier's responsibility is fixed, user's responsibility is fixed. Third one, where multiple sources are used, both, for both the sources you should check this parameter. Actually these are going to make lot of change in the way electrical installations are made. At the moment we are not following all these measures, even though it is written in the standard 33 years back. Now you know very well the regulations on, for example, testing. You see here, regulation 38, the owner or occupier of the multi-storied building shall ensure that the electrical installation and works inside the building are carried out and maintained in such a manner as to prevent danger due to shock and fire hazard, and the installation shall be carried out in accordance with IS 732 and National Electrical Code. Indirectly, National Electrical Code, NEC and IS 732 is mandatory. Hospitals and medical establishment, irrespective of height, this has to be done. So like this, lot of regulations, especially for low voltage consumer premise, there is a complete change. Regulation 33, testing of again IS 732 testing has been included. NBC is included. So with this, I hope I made a platform for the next discussion, the panel discussion. Thank you very much.